We founded Inversion because we saw something in space that was not being exploited yet.
If you can use space for being able to access incredibly remote areas very, very quickly, how can you use that for cargo delivery to deliver items anywhere in the world in under an hour?
Space really facilitates the way this works. We can keep these vehicles up in orbit, and then as they're transferring through their orbits, we can bring them down with very short notice and very limited amount of time for it to get down to the ground.
There is an immediate need in the national security side, primarily in delivery of things like personnel supplies, sensor systems, and autonomous suites to remote locations very quickly. But as we sort of expand forward, we really imagine a world where lots of things are getting built on top of this, and space just turns into the next transportation domain.
Ray was conceived right at the beginning of Inversion. We wanted to get as many learnings as possible as early as possible in the company.
When we were architecting Ray, it needed to reflect a lot of the systems that were ultimately going to make their way onto our next product. And our next product is not just a re-entry vehicle. It is also a fully fledged spacecraft.
Ray is made up of basically two main parts. We have the main capsule or re-entry vehicle that houses the parachutes and like the brains of the vehicle. But we also have the service module. And that is like a fully fledged spacecraft, right? It has its own propulsion system, all of the avionics and software needed to operate in space. We have full control over the vehicle, solar panels, cameras, et cetera, et cetera.
We designed nearly everything on Ray and designed it in-house. What ultimately resulted is a system that was really robust, that was really inexpensive, and was something that our team deeply, deeply understood.
Welcome to the webcast for the Transporter 12 mission.
So day of launch was really exciting. There's kind of this like pre-battle calm that comes over you before the launch.
On the day of launch, I was at Vandenberg Space Force Base. We were actually the closest they had ever put anybody to the launch vehicle, which was really cool. So I got to see it launch in person and the booster come back and land at the launch pad.
We have a list of satellites that are gonna separate from Falcon. We hear the one right before Ray. There's this long pause. Then you finally hear
Ray, separation confirmed.
And that's when the mission really starts.
All right, everybody, now the show begins. We're now going to begin preparation for first contact.
What surprised me really was how well it worked. We received telemetry from the vehicle within 4.5 minutes after separation.
Communications was really a representation of so many aspects of the vehicle working together. So as soon as we got that, it was just like a huge relief that things had really functioned properly. And then we really stepped into the full-on mission operations. So for the first few days, we were running 24-hour mission ops out of our mission control center. I was on as much as I could possibly be awake for as we started to initialize the vehicle and put it into its fully operational mode.
So we get data back from Ray and we're seeing where it is. We know it's healthy. That's an incredible moment for the team, but nothing compares to when we got the first picture down from the vehicle.
You know it's up there, but to get actual proof that it's there and to see the Earth in the background, it was just amazing.
Surprisingly, the exposure was near perfect. It was just happened to be right there, and it was really an incredible sight to just see the vehicle that we had built actually in space.
As part of our mission, we have to do a phasing burn, which is where we fire our rocket engine to align our orbit up with when we're going to do the reentry burn in order to go and land at our landing site. And the phasing burn was one of the first big tests of the rocket engine and the overall propulsion system. We knew it was one of the highest risk moments of the mission.
When we stepped into this operation, this is a long operation, making sure that everything was ready. In kind of the middle of the night, we actually entered into the phasing burn. The vehicle attempted to light its rocket engine, and we saw a number of things go wrong. We saw a lockup on our propulsion control board. Our vehicle began doing a tumble, and we saw no signs of any lighting of the actual engine itself. For most, this would be a really scary time for a satellite, but the operators acted really quickly, very professionally, and our vehicle was robust enough that by dawn the next day, we had fully recovered the vehicle and it was back into its nominal state. We immediately stepped into failure investigation. We did a full anomaly investigation into what exactly had occurred with a number of different tests, both on orbit and on the ground, to really understand what happened. And ultimately, the overall findings were that there was a failed component on board the vehicle that short-circuited when we attempted to fire the spark plug.
At this point, we knew, unfortunately, reentry was not in the cards for the Ray mission. So we started to look at, okay, what other tests can we do while in orbit?
There was kind of one remaining system that we wanted to really test out and demonstrate despite not being able to come back, and that was testing out our full propulsion stack. So we did an orbit lowering maneuver and then subsequently turned it around and did an orbit raising maneuver, both of which were incredibly accurate to the exact orbits we were targeting. And so with that really tested out all of the different portions of our spacecraft, portion of flight.
When you're conceiving of a vehicle, and when you're building out a company to go and fly this mission, one of the ways you motivate yourself at 5 a.m. when you're in the clean room and you're trying to get something integrated is the visual of the parachute deployed and us splashing down in the Pacific, or the vehicle being carted back into the office after re-entering. And so, not being able to re-enter was definitely disappointing. And while yes, Ray was able to perform a ton of other things, not having that satisfying ending lights a fucking fire in us.
It was definitely unfortunate that we weren't able to come back, but understanding that this really wasn't something that realistically would have been caught on the ground and was a pretty novel learning that we had, just really reassured that Ray was an incredible vehicle that we had built. And so I'm super optimistic about where we're heading in the future, and Ray was absolutely a success in its mission of really teaching us a lot of these hard lessons.
So what's next for Inversion is really exciting. Right now, the entire team is focused on our next vehicle named ARC. And ARC is something pretty special. We're going to talk more about it soon, but it is truly one of those products that you will look at and say, wow, the world is different now.
ARC is really a unique product. It hasn't been done before. When you look back at other reentry vehicles like X-37, they are extremely expensive systems. We made ARC so that it lowers the complexity significantly to the point where we can have a much higher cadence and make this a reality for our customers.
I'm super excited to kind of explain more and show more about what we're building. But Inversion is firing on all cylinders, and ARC will be here before we know it.